Smart Culture, Mathematics.
Let's learn more about the sine ratio. The sine ratio, often represented as sin, is one of the primary trig ratios. Specifically for a given angle in a right triangle, the sine of that angle is defined as the ratio of the length of the side, that is opposite that angle, to the length of the hypotenuse, which is the longest side of the triangle opposite the right angle. So what we'll do now is we'll draw 4 different triangles. Let's start with the first one. So for angle A, the sine of A is equal to 1/5. Remember, the sine ratio for a given angle in a right triangle is the length of the side opposite that angle divided by the hypotenuse. And in this case, the hypotenuse is equal to 5. So this ratio 1/5 tells us that the angle A is relatively small, resulting in a shorter side opposite it compared to the hypotenuse. Let's move on to the next triangle. So here we have angle B. Now for B, the sine of B is equal to 2/5. So the side opposite angle B is 2/5 the length of the hypotenuse. This means angle B is larger than angle A, giving us a longer side opposite it. What about the next triangle? Here we have angle C. Now the sine of C in this case is equal to 3/5. So here, the side opposite angle C is 3/5 the length of the hypotenuse. And this also means that angle C is larger than both angles A and B. Let's take a look at one more triangle. Here we have angle D. Now, in this case, the sine of D is equal to 4/5. So the side opposite angle D is 4/5 the length of the hypotenuse. This is the largest angle among A, B, and C, but still smaller than 90 degrees since its sine value hasn't reached 1. Now, if you punch the sine of 0 degrees into your calculator, you'll get an answer of 0. Let's see why. So when angle theta is equal to 0, it means that in this case, there is no height or opposite side because the triangle collapses to a straight line. So the sine of theta in this case, the sine of 0 degrees is equal to 0 divided by the length of the hypotenuse. And this is equal to 0. So if you imagine a right triangle with a 0 degree angle, in other words, a flat triangle, the length of the side opposite the angle is 0. So on a number line, this places us right at the origin. If you punch the sine of 90 degrees into your calculator, you'll get an answer of 1. So in this case, angle theta is equal to 90 degrees. So the side opposite the 90 degree angle is the hypotenuse itself. Hence, the sine of 90 degrees is equal to the length of the hypotenuse divided by the length of the hypotenuse, and this is equal to 1. Let's visualize all of this on a number line. So starting from 0, representing the sine of 0 degrees, the value of sine increases as the angle goes from 0 degrees to 90 degrees. So the values for our triangles would be plotted as the first triangle with sine of A is equal to 1/5 will be plotted somewhere close to the start. And then the second triangle where we said that the sine of B is equal to 2/5, this angle will be plotted a bit further along. Then the third triangle with the ratio 3/5 will be plotted even further. And then the last triangle with angle D will be plotted very close to the end. But not at the maximum value of 1. So this pattern visually illustrates that as the angle in a right triangle increases from 0 degrees to 90 degrees, the sine ratio also increases from 0 to 1.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.